1, exam 2 review. For the exam 2, which opens this weekend on chapters 3 through 5, partially of 3 of 5, not all of it, but could be. So I'll go through there. It'll be some multiple choice, much like exam 1, and some short answer problems. And you'll get one attempt, and same as before. And the short answer problems will be manually graded by me once the exam closes. So you'll look up for the exam dates, and there we go. All right, so that's exam 2 review that we'll be doing. I'll go through the topics briefly. So I've done the lectures for chapter 3. All right, main thing is vectors. All right, the difference between that and a scalar. So again, a vector has a direction, a magnitude, like a force, while a scalar is just like kilograms, right? Something is 10 kilograms. Doesn't matter where it is. And for this, again, we'll be going over, all right, section 3.2, definition of vector, all right, graphical method of addition. All right. That includes section 3.2 and 3.3, so keeping in mind about, if A is this, then minus A is in this, just the same vector in the opposite direction. Right, so that's it there. We're not going to do anything on the component method of vectors. Just keeping in mind that the angle is defined from the horizontal, unless specifically different, and this is the x direction, this is the y direction, so that's the y component, x component, right? And then don't forget about Pythagorean's theorem. If this is r squared is x squared plus y squared, so I'll get you the magnitude. Okay, so that's the first part. It's possible there could be a problem on projectile solving, projectile motion problems, such as when something is launched horizontally and it falls a distance y and travels a distance x when it falls. So this is part of section 3.6. That'd be the only kind of problem I'd have there as far as that's concerned. All right. And go from there. So that's section 3.6. And then on section 3.8, all right, relative velocity, I went through that. And if we have, say, crossing a river, it's probably an example or something like that. All right, you've got a river, it has some velocity, and you either want to cross straight across, in which case you have to aim this way, so you end up being pulled that way. So this would be A, this would be B, and then C. So A plus B gets you C. Or the other option is you go straight across. All right, you go straight across A, and you get dragged down by B, and then C would be here. So in both cases, A plus B, but here you get A, you get pushed so you end up going straight across. Here, if you aim straight across, you can get drifted by there. And again, the distance X is again, keeping in mind, velocity is distance over time. So X will be velocity times time, or time, or time is distance over velocity. So that's the relationship between all three of these. All right. So that's chapter 3 as far as the test is concerned. Possible problems related to that. Okay, so that's chapter 3. We go on to chapter 4 then. All right, so chapter 4, Newton's laws of motion. All right, and this includes, let's see, first law, which is section 4.2. All right, motion, object motion stays in motion. Definition of force will come into second law, which is F equals MA. Which is section 4.4 in the text, and examples related to that. Second and third law, action, reaction. All right, this will be more an intuitive type of thing, conceptual type, section 4.5. Leave that there for the moment. Okay. Again, problems related to that. Section 4.6 on weight, which is given by mg, where g again is, if we're just using just plain weight, is 9.8 meters per second squared. We consider it downward, so weight is mass. So again, but technically it'd be downward, so it'd be minus. And related to that kind of problem, so weight there. Then we have, what do we have here? Oh, yeah, and related to that, right, weight in accelerating elevator, and I went through all this before, so whether it's accelerating up, which would be plus A, or down, which would be minus A, how your weight changes when you accelerate up or downwards, and that's part of section 4.8. 4.6, I should say, or 7. 4.7. Right? And then, okay. Then the last section, 4.8, is friction, where we define friction is mu m times the force of gravity, force of weight, And again, we have either mu kinetic, mu static, or mu kinetic. And I'll give you the different, if you actually have to solve a problem, I'll give you that. All right? So that's chapter 4 as far as the test is concerned. All right? And moving on to chapter 5. Okay. Oh, I should say related to this, we also had the Atwood machine. And the problems that could occur for that. I'll erase this up here. Problems related to that would be either hanging, M1, M2, or we have a frictionless surface, M1, a pulley, and M2 pulling down. So these are the cases you can have as far as that's Atwood machine, and then how we relate force and gravity. Again, it's all related to force. It's mass times acceleration, and the fact in both cases these move together. So the combined mass would be M1 plus M2, that's being accelerated, but the force depends on how these are configured. So that's the last part on chapter 4. Again, that's from the lab on the Atwood machine. All right, so moving on to chapter 5. All right, so chapter 5 is circular motion. And gravity. So for chapter 5, we defined 5.1, all right, is centripetal acceleration is v squared over r. So it's a speed that is traveling in a circle divided by the radius. And as far as that's concerned, so I've gone through that. Related to that is the period is 1 over the frequency, and the speed is 2 pi r over the period, all right? So the speed that's moving, so 2 pi r, so 2 pi, so r, the circumference is 2 pi r, and the period is how long it takes to go from one back to the same spot. So that's section 5.1. Okay. All right. And how we define that. Oh, yeah, 5.2. All right, 5.2. So circular motion, vertical, circular motion, due to the fact that we have, as in a circle, we have gravity, force of gravity is always pulling downwards. So how does that vary, whether you're at the top or at the bottom? Pull when you are going in a sort of like either on a roller coaster or pulling on a string, how far that goes. So that's section 5.2. Okay. I did some examples of that before. 5.3 is friction on a turn. All right, so we have turn, radius r. We have centrifugal force sort of is pulling it out. So that's mv squared over r. And the frictional force pulling it in is mu mg. So depending on how the configuration, what forces balance so that it stays on the track. You know, if this is too much compared to that, then it'll slide off the track. And that's part of what we talked about. Did some examples with different types of surfaces and how it relates to static coefficient of friction and sliding coefficient of friction. I'm going to do nothing on inclined planes as far as that's concerned. All right, so the next section will be on gravity. Okay. Law of gravity. And this is a force of gravity is Gm on Earth, M sub E, M1 over R squared. Where again, R is the distance from the center of the Earth. So if you want, or the center, so any object, M1, M2, R is the distance between the center of the two objects. So if you're on the Earth, it's a very large radius as far as that's concerned. Okay. And then I got into 5-6, gravity. Near surface, Earth surface. And compare that to, this is 5.7.2, you know, orbit, satellites, orbit, right, space station, which is about 300 kilometers up. How does gravity compare there to gravity on the Earth and the feeling of weightlessness? What does that mean? Okay, all right. And then related to that, and then orbits. All right, related to part of the same section is geosynchronous. Orbit and orbit of moon. Moon's orbit. All right, like how far away in the period, like what is R in the period for each one of these, comparing it to a low Earth orbit. Same for the moon's orbit, how far approximately, how does that period relate, and how this is related to Newton's law of gravity. And that is basically all of it there. I'm not going to do anything on Newton's laws of Kepler's laws, which is section 5.8, or forces. So that'll be the last part there. So I'm not going to go anything to orbits of planets around the sun, other than it's the same kind of concept. So these are related to orbiting the Earth. So all of these are, orbiting around the Earth. So low Earth, like space station, geosynchronous, moon's orbit. So that is chapter 5, and that's the review for exam 2. Okay, so I need class on Thursday to answer any questions about it and go from there.